Yes, dear students, I request you, you may uh, ask your friend to subscribe this channel. Actually, what will be there? You will get the video as soon as I upload on YouTube. So, in the benefit of students, please, first of all, you subscribe the channel and then ask your friend to subscribe the channel. And then you can discuss together the video if you are close friend and live in the neighborhood or anywhere else. You can discuss the video and try to understand is the and the subject. Now I come here to new topic which is very important. Generally, students and teachers don't pay attention to this topic. While topic is very important, and the topic is conservative force. Conservative force and non-conservative. Non-conservative. In fact, I was having in my mind that I should be able to teach everything to my students, and what we teach is beneficial or not to students is learned after observing the question papers of different exams, competitive exam as well as board exam. So in many competitive exams, I have seen lot of questions based on conservative force, and basically it helps to understand physics further if we know conservative force. So what is conservative force? Sorry, ये रब हो गया भाई. Conservative force. Concept of conservative force is very important. Just like people say, where the conservation law applicable? No. Actually, if the work done, by a force or against the force, in carrying a body from one place to another. I started if the work done by a force or against the force in carrying a body from one place to another, or from one point to another, does not depend on path followed. Then force is called conservative force. Dear learner, every learner remain in hurry to learn the things, but things in hurry are not learned. They can be read only. In hurry you can read, but not understood. think over what you are going to read and what is the concept. When generally in paper I have seen students write about conservative force, they start writing the force which does not depend on path followed. Force, not the force. If the work done by the force. Students are in the habit of telling the thing very quickly and promptly. My question is that, okay, what is conservative force? So in exam I have checked so many copies where it is written that force which does not depend on path followed. Not the force, it's the work done by the force. It is the work done which does not depend on path followed. And who does the work? Force. If the work done by a force in carrying a body or work done against the force in carrying a body does not depend on path followed, then that force is called conservative force. And the fields. Now for you the term field is quite new. Like gravitational force is in the gravitational field of Earth. The fields in which conservative force exists is called conservative force. Conservative field. Conservative field. So for example, gravitational force. Electrostatic force. What is electrostatic force? Force between charges when they are at rest. Conservative, no? For example, gravitational force, which is that force applied by Earth to attract a body towards center, or force applied acting between force of attraction between two bodies due to their mass. Gravitational force, electrostatic force. Which one is that? Which acts between two charges when they are at rest. Electric force, magnetic force are conservative forces. You will learn many properties of conservative force, but more important thing is that conservative force is that by which or against which work done does not depend on path followed. And the gravitational field, they are filled by attraction of Earth, filled around a charge in which other charge and force is called electrostatic field, and filled around a magnet in which other magnetic action force is called magnetic field. These are also called conservative fields. Now you may be thinking, I am using the term work done by the force or against the force. Earth attracts everybody toward its center, and that force is called gravitational force. So when you are lifting a body to certain height h, you are doing the force applied by you is in the direction of displacement. And while defining work, I told the meaning of positive work. But gravitational force acting downward. So gravitational force is acting downward, so work is being done there against the gravitational force. So if the work done by a force or against the force in carrying a body from one place to another, does not depend on path followed. That force is called conservative force. We will learn it against the force again. Actually, we are lifting the body, we are doing the work against the force. External force we have applied. The force of attraction between earth and body is called internal force between the two. Now, if we take this body in our hand and lift it certain height, if I release, it will go down. Why it is going down? Because of gravitational force of earth. We will learn a thing here, very important. Actually, in general teaching in classes, I always try to teach everything which is related with the definition of concept or anything related to concept. I never saw what is the syllabus. Actually, people teach in class the specific topic written in syllabus, but there is some hidden syllabus which is based on the application of the topic taught to you. So that way it becomes very difficult. Once there was a question in the 12th exam. There is one microscope which uses lenses. Image formed there because of light reflected from the object. That is called optical microscope. There is another microscope, electron microscope. So there is a term resolving power. So electron microscope has much higher resolving power than optical. So this was asked in the exam. While electron microscope is not in syllabus, but resolving power in syllabus and the working of electron microscope is based on matter wave. Matter wave are taught. That is an application of matter waves. So question was asked, teacher was saying, sir, it is out of syllabus. I said, no. You teach matter wave, yes. You teach resolving power, yes. You teach how the resolving power depend on wavelength of light, yes. Then why do you say it is out of syllabus? No. So please learn each and everything. Now I come to non-conservative force. Non-conservative force. What is this? Simple word. जो कंजर्व नहीं है, नॉन कंजर्व, बट कौन नहीं होगा नॉन कंजर्व? If the work done by a force or against the force, if the work done by the force or against the force in carrying a body from one point to another, depends on, here work done depends on path followed, then the force is called non-conservative. So if the work done by the force or work done against the force in carrying a body from one place to another does not depend on path followed, is called non-conservative force. For example, the very common example is force of friction. force of friction. Force of friction is very common example which you see daily. The work done depends on path followed, and that work done actually work done by frictional force converts energy into heat, light and sound. It is not, one more example is there, but you will be able to understand while learning properly in class 12 the concept of electric field, magnetic field, electric generator and electromagnetic wave. So electric field produced by varying which does not remain, which keep on changing. Varying is changing by varying magnetic field. By varying magnetic field produce non-conservative force. Non-conservative force. This is very important example here. So conservative force you have got the force by which work done. I am stressing again, I am speaking again and again, so that it becomes fixed in your mind. If the work done by force or against the force in carrying a body from one place to another does not depend on path followed, that is conservative force. And if work done by a force against the force in carrying body from one place to another depends on path followed, that is conservative field. In conservative field, work done over a closed loop remains zero. You will learn so many things. Now here, in next video, I will take one important topic, that this conservative force is equal to the negative of gradient of potential energy. Gradient word. This gradient word is very new for you. Gradient. When any physical quantity varies with distance, so that quantity divided by distance, delta Q upon delta X. Whatsoever is the quantity, maybe energy, maybe work, maybe temperature, maybe potential, then we use gradient. Potential energy, is function of position. The potential body at ground, according to MGS, you take 0, but as it is distance increases, potential energy changes. So potential energy is a function of position, distance, not path followed. So in next video I will prove that this conservative force is negative of potential gradient, negative of gradient of potential energy. Thank you.